Okay, so let us continue discussing the problem. So one question of NCERT in the last class, I interpreted it in a different manner, although that confusion may be because of the language of the question. Okay, that's why it has to be very clear from the questioner side that they should put the question with clarity. Anyway, let us discuss that question again. Okay, so the question is question number 3, it is 8.3, question number 3 in CRT. What physical quantity is same for X-rays of wavelength this, red light of wavelength this, and so they are saying that there are three electromagnetic radiation. One they are saying X-ray, another they are saying red color light, red light, which is nothing but visible, part of the visible light, and another they are saying is radio waves, radio waves, right? So like these three electromagnetic waves they have given. Okay, so this clarification we want to do, because last class we have interpreted in different manner. So when they ask question, this is a possible interpretation. Okay, it's not that it is wrong, it's a possible interpretation. What physical quantity is same for, they are saying what physical quantity is same for X-rays, and if they simply say that what quantity is same for all these things, then we can give the correct answer. But they have given some values, and so there is a other way kind of interpretation can happen. So last class we tried to compare the numerical value of that. Okay, so they have given the wavelength for this X-ray. This X-ray wavelength they have given us 10 to the power minus 10 meter. For red color light, the wavelength they have given as 6800 angstrom, and for radio waves the wavelength was given as 500 meters. So what I compared is the numerical value, because which physical quantity same means uh, similar to this 10 to the power minus 10 meter means 1 angstrom. What is same as 1 angstrom? That I misinterpreted it. Might we can call misinterpretation, but I believe that there is a part of clarity needed in that question. So what they are saying at what is common, might be they must have said what is common. What is common thing for all these electromagnetic waves? That would be a proper question. But now you take care while you read questions in NCERT particularly, there are interpretation in different way also possible. So question is actually saying that what is same for all the different kind, not only for these three. For any kind of electromagnetic wave, what is same they are asking. What is same is their speed is same in vacuum, that's all. That we already know, that electromagnetic wave travel with the speed of light. Electromagnetic wave travels with electromagnetic wave travels with a speed equal to 3 into 10 to the power 8, nearly equal to this meter per second in vacuum. Of course, in different medium, speed become different, but all electromagnetic wave has this speed, common speed. Okay, that's what I think they mean to say in that portion. That's the, I check with the key, they are meaning this only in this question. Okay, clear? All of you are clear about this? Then other questions we have discussed. What about the next question? Question number 5 we have discussed. Question number 6 we have discussed or not? Question number 6, did we discuss? Charge particle oscillator, what's the frequency? What is the frequency of? We have finished. Up to how much we have finished? 8.7 we finished. Let us go to 8.8. 8.8. Suppose the electric field amplitude of an electromagnetic wave is, okay, amplitude is given 120 Newton per Coulomb, and its frequency is frequency. I am writing frequency as F, okay. Sometimes they use different symbol, but let's not get confused with that. So 50.0 means 50 megahertz it is. Determine, we need to find B naught, amplitude of magnetic field, omega, k, lambda. This is the first part of the question. Second part of the question is find expression for electric field vector and magnetic field vector. This expression we have to find. Okay, they have not given which direction it is going, but anyway, take a general direction and try to solve it. So first of all, let us calculate frequency they have given. Okay, so omega we can calculate. And what is the speed? They have not given speed. Speed we cannot say. So that means you take in vacuum. Nothing is given means vacuum you take. The speed of light in vacuum, you know, 3 into 10 to the power 8 meter per second. So all of us know that E naught by B naught ratio is equal to C. So from here B naught is equal to E naught by C. Let us substitute here. So this is given as 120 divided by 3 into 10 to the power 8. So this will become 4 into 10 to the power minus 7. Tesla is the unit. So that's the answer. B naught we got it. Then omega is 2 pi into frequency. Frequency they have given will multiply. Frequency is 50. 50 mega it is. 50 into 10 to the power 6 it is. So that become pi into 10 to the power, this become 100, 10 to the power 8 it will become. Radian per second is the unit. Okay, so this is what is omega. Okay, then k. What is k? K is equal to, okay, one thing we know, omega by k is equal to speed in vacuum only, right? So from here we can calculate k. K is equal to omega by c, right? Omega is pi into 10 to the power 8 and c is 3 into 10 to the power 8. So that becomes 5 by 3 and the unit of k is per meter, so meter inverse. That's the k. Then what? Lambda. Lambda k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k. So 2 pi divided by k is pi by 3. So lambda becomes 6 meters. Right. Over. So first part is over. Next electric field vector let us write. Because they have not given anything, right? So we know the standard, directions. This is x-axis, this is y-axis, z-axis. Electric field vibrates along, let us take y-axis. Magnetic field vibrates along z-axis, and the wave propagation happens along x-axis. If you take this standard form, then electric field I can write as a vector as E naught. E naught is already given in the question. I will write the equation here. E naught sine kx minus omega t, and this is along j cap. B vector is B naught sine kx minus omega t. This is along z axis k cap. You can substitute values in this expression, right? And you can just write that. Okay, so E naught value is substitute, K value is substitute, omega value substitute. Here also B naught substitute, K substitute, omega substitute. That will be the equation. Okay, so like that we can write it. Clear? All of you are clear about this? Okay. Then next. Go to the next question, 9. Question number 9. So NCERT, definitely we must not leave any question. We must solve as much as possible. The terminology of different parts of electromagnetic spectrum is given in the text. Use the formula E equal to h mu for energy, quantum radiation, photon of 10 photon energy in terms of electron volt for different part of electromagnetic spectrum. In what way are different scale of photon energies that you often related to the source of electromagnetic radiation? In what way are different scales of photon energy that you obtain related to the source? See, first of all, the energy formula of photon energy is H is equal to H into frequency, right? Or E is equal to hc by lambda. That also you can do, because speed is equal to lambda into frequency. So frequency can be written as c by lambda. That's what we substituted. So you can use any of this. If you know lambda, then use this. If you know frequency, then use it. But the question is that you have to keep the energy in terms of electron volt. Okay. So what is electron volt? First note that 1 electron volt is energy 1.6 into 10 to the power minus 19 joule. Okay. So whatever the answer you will get by substituting frequencies in SI unit, you will get in joule. Then you need to divide by that factor 1.6 into 10 power minus 19. Then you will get in electron volt. Okay. So that calculation you have to do. They are saying that you do this calculation for all the electromagnetic radiation. Okay. Obtain the photon energy for different parts of electron. Different parts means what? Different parts means what? Different part means, let us say, gamma rays. Start with gamma rays. So gamma rays start. So gamma rays, do we know frequency? Tell me frequency of gamma rays. In CRT only you refer. Okay. Or wavelength you see what they have given in CRT. They have given wavelength about 10 to the power minus 10 meters, less than 10 to the power minus 14. Okay, so wavelength, if you see frequency, forget what frequency, they have given wavelength. If you have the idea of frequency, then it is better, but frequency, I think they have not given frequencies. Did they give that? Ah, yeah, table 8.5, you see, they have given some order of frequency. So, but it's a range. Which range of frequency shall we take? Because frequency is given from 10 to the power almost 19 to 10 to the power 23. Which range shall we take? Shall we take 10 to the power 21? Okay, let us say that it has frequency of 10 to the power 21 hertz. Let us say, because they have given a range of frequency, now take the middle part, take the average frequency. Okay, the middle part, and we take 10 to the power 20 or 21, you can take. Okay, now calculate the energy. Energy is equal to h into frequency. H is 6.64 into 10 to the power minus 34. Frequency is 10 to the power 21. So this becomes 6.64 into 10 to the power minus, subtract that 3, and this is 13, correct? Okay, this is joule. I want to convert in electron volt. Convert. So divide by this 1.6 factor. So 6.64 into 10 to the power minus 13 divided by 1.6 into 10 to the power minus 19. This you calculate nearly 4 times it will come. Nearly 4 times I am approximating it. Okay. Because 16 into 4, 64 nearly. Into 10 to the power, this 19 minus 13, it will come 6 electron volt. Okay. So what we are getting is this energy of Gamma rays are coming nearly 4 million electron volt or mega electron volt. Like that, you have to calculate the, you need to do the calculation like that way. Okay, that means here only frequency the 10 to the power will only change. If 10 to the power changes, according to, but other factors will remain same, right? So this is, that means 19 minus this power you have to do, means whatever that power comes out. Okay, so let it be like this. Okay, you can do calculation for, but what they are asking is that for all the different radiation you calculate like this. Okay, how much electron volt comes, maybe million electron volt or kilo electron volt or whatever it is, that it will come. Now the second part of the question, what they are saying is, they are saying that what is the source, means they are asking some question related to the source. In what way are the different scales of photon energy that you obtain related to the source of electromagnetic wave? So how is this energy related? How this energy is related? How this energy is related to the source of electromagnetic wave? That is the question. Okay. So how do you know that? Because this energy 4 million electron volt is quite large energy. Okay. So if you calculate this energy for all others, it will come less. So it is large means it gives the idea about the source. So the source of this is gamma rays, right? Gamma ray source is nuclear reaction. So nuclear reaction produces very large amount of energy. Okay. So that is why we can say that because nuclear reaction produces very large amount of energy, so these photons have very high energy, photons of gamma rays, right? Similarly, if you consider radio wave, let us say that you talk about radio wave has the smallest frequency and its energy will come very small, right? So from that energy you can convert into electron volt, and then you can say that this energy is very small because radio waves are coming from a source which produces less energy. That's all. How is radio waves produced? Radio waves are produced in laboratories, right? That LC oscillation circuit. So that LC oscillation circuit energy is very less. Because of that, it is very less. Clear? Yes. So question is good, but question is they are twisting it. We need to capture what is the essence of the question. Okay. So the energy of the photon gives an idea of the energy of the source which produces electromagnetic wave, right? That is the idea. Then next question will go. Question number 10. So like this you have to do for all others. At least when you do it, I will recommend that you do it. Okay, for all waves, all electron, because you'll get some idea about the energy of the photon. Photon energy idea you will get. Each photon, like X-ray photon, gamma photon, visible light photon, or radio wave photon. What are the energies of that? Some rough idea is very much important to know for estimation. Okay, then let us go to the next question number 10. In a plain electromagnetic wave, the electric field oscillates sinusoidally, so frequency is given as 2 into 10 to the power 10 hertz. Then amplitude of electric field E naught is given 48 volt per meter. Then what? They are asking questions on that. They are asking wavelength. They are asking amplitude of magnetic field B naught. Similar type of question is coming. Then they are asking this, so that average energy density of electric field equals the average density of. So we have to show that average energy density UD in electric field average is equal to energy density in magnetic field average. We need to show that. Okay, and to show that this, in order to show this, you have to definitely use this relationship that the speed of light is 1 by root mu naught epsilon. This idea definitely you use it. And also you use this relation that E by B ratio or E naught by B naught ratio is equal to C. This relationship also you can use. So these and these two relations you use, you can definitely prove this. First let us do this calculation. So energy is given, frequency is given, wavelength they are asking. So energy, no sorry, not energy, this is electric field it is. Okay. Wavelength they are asking. So what about speed of light? They have given in the question, take speed of light in vacuum 3 to 10 to the power 8 meter per second. So now we know speed and we know frequency. So speed is equal to lambda into frequency. So lambda is speed by frequency. Just divide it. So 3 into 10 to the power 8 by 2 into 10 to the power 10. So lambda you calculate as 1.5 into 10 to the power minus 2 meters, right? Or 1.5 centimeter also you can write. Right. So you got lambda 1.5 centimeters. Then what else? Magnetic field, same way, magnetic field is what? E naught by C you will use. E naught they have given 48 by C is 3 into 10 to the power 8. So 16 into 10 to the power minus 8. Or 1.6 into 10 to the power minus 7. Right, Tesla. Next, how to prove this? We should know these two equations and then let us prove that. We already have done the proof for this. So energy density average. First let's write energy density formula. So half epsilon naught E square, right? This is electric energy density. Now if I take average, because you know that E formula, E is the electric field which is E naught sine omega, sine kx minus omega t. So when you substitute E here, it becomes half E naught square, sorry, epsilon naught is also there, half epsilon naught square of this E naught square sine square this term kx minus omega t. And when you take average of this, suppose if I take average, so if I take average, so you remember sine square average become half. So this is anyway half epsilon naught E naught square, and that factor half comes, this factor half is coming because of sine square average. Sine square average is half. Similarly, you calculate energy density in magnetic field. So similarly, it will come like that only. Similarly, that formula is 1 by 2 mu naught, right? B square. But when you take average, it will come B naught square and that factor half. This again half factor is coming because it is the average of sine square function. Okay, so like this you will get these two things. Now we need to make them equal by using these two equations. Use it. So let us say that I want to convert this one. Let us take this B naught. So let us put B naught from here. So B naught will become equal to E naught by C. So 1 by 2 mu naught. B naught become E naught C. So E naught square C square you will get. And this is 1 by 2. Right. So then what? C square. Now let us substitute C. So C is this. C square become 1 by mu naught E naught. So 1 by 2 mu naught E naught square C square, if I substitute, it will become 1 by mu naught epsilon naught, 1 by 2. So here you will see that this mu naught terms will get cancelled, right? This you will get that epsilon naught will come in numerator now by 2 E naught square, and this extra half is coming. Now it is the same only, right? You got this, right? Now check, this is equal. It should become equal like that. Okay, so like that you can prove in NCERT in board exam it is coming. then you have to use these two conditions. These two conditions must be used, then only you can prove it. Okay, energy density average is equal in volts. Clear? Done? Anyone any doubt? Do you have additional questions in the updated NCERT book? Did they give any additional questions? Yes. Satresh, Sam, Lalit. You have the NCERT book now. Check that. Is there any additional questions? No additional questions. Okay. So that is done. But now if you see old NCERT book which we have there in our app, there are some extra 5 additional questions are there. Okay. So I will recommend that you go through this extra. They are good questions. Okay. They are definitely very good questions. For your NEET level, also for JEE Main, JEE Advanced level, these questions are very good. You go through these questions. Okay. There are total 5 extra questions are there. Then this chapter is done. But now there are some questions which are critical questions which you need to note. Some important conceptual questions which may come from this chapter. Okay, what is that? So first thing that uh, question is, electromagnetic wave can electromagnetic wave be produced from RC charging circuit? We have told that electromagnetic wave can be produced from LC oscillation circuit, right? Because electric field is oscillating or magnetic field is oscillating, because charge is oscillating, current is oscillating, so electromagnetic wave is produced there. But in RC circuit, if you say, which is a DC circuit basically, you are connecting it with a battery voltage plus minus, and there is a switch you are keeping, and there is a resistor also you are keeping in this circuit, right? RC. And you know, when you this type of circuit we have seen in displacement current, right? When we discuss displacement current, when you switch on at time 0, the charge changes here, right? Charge is equal to CV 1 minus e power minus t by RC. Remember this formula. So note that this charge here, plus charge will appear and minus charge will appear, plus q minus q, right? So charge is changing, and because of changing charge, electric field is also changing, and because of changing electric field, we have seen that there is magnetic field which is also changing, and that changing electric field, magnetic field will produce electromagnetic wave. But the thing is that here, once this capacitor become fully charged, let us say once the capacitor become fully charged in a steady state, after that charge will not change, you know that, right? For time equal to infinity, very large time at a steady state, what happens? At a steady state, when time becomes infinity, charge will become CV, because e power power minus infinity is 0. So charge becomes CV, charge will become constant. So charge will not change. But before that, any other time, if you take, charge is changing, electric field is changing, there must be electromagnetic wave. But the thing is that electromagnetic wave is not going to be sinusoidal function. So very important to note that here electromagnetic wave are produced electromagnetic wave is produced in DC circuit also. Is produced, but it is not it is not sinusoidal. Sinusoidal is there only when sinusoidal is only when it is oscillating in simple harmonic, right? But here the electric field change. So remember very important point. So whenever there is electric field is changing with time or magnetic field is changing with time, there is electromagnetic wave. Okay. So that point you note. If electric field changes with time, if electric field is time varying, this word also you can use. If electric field is time varying and magnetic field is also time varying, it will automatically become time varying, right? Because if electric field is time varying, it will produce time varying magnetic field, and that will produce this. But the thing is that if it is like this, if electric field is time varying and magnetic field is time varying, it produces electromagnetic wave. It produces electromagnetic wave. But the question is whether it is a sinusoidal wave function or not, that will depend how it is varying. How it is varying. Suppose the variation is sinusoidal, sine function or cos function, then it is sinusoidal wave function. But if it is not a sinusoidal wave function, it may be other kind of function like log function, exponential functions like that. Like for example, here it is a exponential function. Exponential function. But here another point to note that I told already when steady state happen, after that electric field does not change. So this circuit will produce electromagnetic wave till steady state. Once steady state is reached, after that it will not produce electromagnetic wave, because after that electric field will become constant, charge will become constant. So this produces electromagnetic wave up to steady state. But the wave function is not sinusoidal wave function, that is some exponential wave function, right? That is what you need to note. And also the electric field strength is decreasing. Yes, initially it may increase, sorry, electric field is increasing, but the rate of increase decreases here. That means suppose initially there is no electric field, then suddenly electric field is increasing. As the charge is becoming more mature, after that there is no. Because if you see the graph, let us see the graph of this. You already know the charge graph, right? Charge versus time graph, you know in this. So charge versus time graph goes like this and becomes like this. So it develops a maximum charge which is CV, that happens after infinite time. So that means you can see the slope. Slope of this graph is decreasing, right? Slope is decreasing now because here slope is more. Now slope is less. Finally, when it becomes maximum, slope will become zero. Clear? You can see this. Slope becomes zero. So the rate of uh, change of the slope, that means you can say current is gradually decreasing, and as current decreases, magnetic field which is produced, that also decreases. So the important point to note in this circuit is it also, but nowhere it is written. If that's what question asks, question in a NEET or in JEE, they ask on a common thing which nobody question it, which is missed in general public. They ask that type of question. So if they ask that is this RC circuit produces electromagnetic wave? Yes, it produces electromagnetic wave because it has time varying electric field magnetic. But after the steady state it stops producing. Why? Because there is no change afterwards. So you can say that it is producing electromagnetic wave, but it is a transient. Transient means for some time, that's all. After that it doesn't produce. This example can be understood very easily by equation, by taking example of a how wave is produced in a rope. Let us take this example. How wave is produced in a rope. Suppose for example this is a rope which is connected like this. Okay. and this is the free end of the rope. This is the free end that is fixed end. Now, when you move this point up down, suppose you move up, you move down. One time, if you do up and down motion, what happens? You will produce a pulse like this on this rope, right? You will produce a pulse. Let us say only one time you do. After that, you stop. If you stop it, then this pulse will be moving in this rope. It will go from left side to right side. You will see that. Okay. So this is what is pulse. It is called pulse, right? This pulse you have produced. After that, you are not vibrating this, so it will go and it will go that side. It may hit the wall and all, but it will be lost, right? This energy will be lost. But if you want to produce a wave, electromagnetic wave, if you want to produce, you have to continuously keep on vibrating, right? Continuously you have to vibrate. So suppose if you vibrate this point continuously means you move up, ring down, move up. That means about the mean position, and between the extreme position you keep on doing like this. So if you keep on doing like this, there will be wave produce. Continuously waves will be produced, right? So this wave which is produced is called wave. This is called wave, this is called pulse. Pulse is nothing but it is a single disturbance. Pulse is a single disturbance. But what is wave? Wave is a continuous disturbance. Wave is continuous disturbance. Wave is continuous disturbance. So same way, if they ask in this RC circuit, is wave produced? Yes, wave is produced. That is like a pulse, you can say. But after some time it stops, right? Because you are not continuously vibrating the electric field and magnetic field. So the wave, electromagnetic wave is produced, but it is not continuous, it is transient. Transient electromagnetic wave is produced. Okay. But if you take LC oscillation circuit, their continuous wave is produced. That's why we say electromagnetic wave is produced. Are you getting this idea? Yes. Okay. And why this wave is called sinusoidal? Because it is vibrating up and down in a SHM. This is going SHM. I think SHM equation you know. All of you know SHM equation. Suppose it is going a y distance up and y distance down. So acceleration of this particle acceleration is equal to minus omega square y. This you know, right? This is called SHM. Acceleration is proportional to minus omega square x or y, right? Displacement. So because this particle is moving in this manner, that is why it is called sinusoidal wave. Okay. So similarly, in that case, the particle is not moving sinusoidally in this RC circuit. That is why it is not a sinusoidal wave. Okay. But in LC oscillation circuit, the electric field, magnetic field is changing in a sinusoidal manner. That is why it is called sinusoidal wave. Got it? Yes. This question is a hidden question, is a secret question they can ask sometimes. In the textbook, you will not to find this clear given. Done. So then this topic is over. Anything else is there in this topic? Yeah, I think the calculations of intensities are there that I will highlight with few problems. Intensity calculation. So intensity due to a source of electromagnetic wave at a distance. So suppose that, let us say for example, suppose there is a source. This is a source of electromagnetic wave, source of EMW. Source of EMW means, let us say electric bulb. Electric bulb is a source of light. It is producing light which is going in all direction. Okay. So light radiation is going in all direction from here, 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 Radially in all direction light rays will go, or light energy will go. Now suppose if they say that what is the intensity at this point, or if they ask what is the electric field amplitude of electric field at that point, what is the amplitude of magnetic field at that point, how to calculate? That type of question can come in NEET or JEE. Okay, so suppose this point is, let us take point P, which is at a distance of r from here. So first what you need to do is you need to make a sphere, take this as center and make a sphere like this. Okay, make a sphere. Then what you need to do, you need to understand that whatever energy this source is emitting, that energy is getting trapped within this sphere only. Within this sphere all this energy is being captured, right? Let us say that source has a power, the source has power, output power we are talking about. Okay, output power is equal to P. Output power means this is the output power. Input power may be something else, because suppose they say that electric bulb is 100 watt, but when you use it, it may not be exactly 100 watts, because maybe some loss of energy happens. It may be 90 watt, like that. So we are talking about the output power, like 90 watt we are talking, actual output power. So this is output power. So this bulb has power. We have to calculate intensity here. So intensity definition, if you see intensity definition, intensity is energy per second, that means time, by area. That is what it is, intensity. Now see, the energy means the total energy. When we talk about energy, that means total energy. So let us understand here that suppose this source is emitting photons, right? Photons only it is emitting. So the photons which it is emitting, let us say it is emitting photons. Photons. These are photons. Let us say that this is photon. Let us say that these are n photons. N photons. N photons it is emitting, and same n photons will be reaching there. Okay. Same n photons will reach there. So total energy will be n into energy of each photon divided by time into area. Here area which you need to consider is the area of this sphere, because all this photon will be hitting this, right? All this photon will be hitting this area. So you need to consider this area of this bigger sphere. That area only you have to take. So that area become area of the sphere, which is 4 pi r square. Okay, so note that energy, total energy by time, that is what is called power. Power by 4 pi r square. This is the formula for intensity at a distance r. This is the, let us write intensity as I. So this is the formula for intensity is equal to power by area. Now once you calculate intensity, right, you can also calculate the pressures. That P is here the power. But if they ask what is the force on this sphere or what is the power, then how to calculate that? So I think radiation pressure formula we know, we can use radiation pressure formula to calculate. In intensity we will use this, right? But coming to the calculation of intensity, this formula of intensity we'll use. But suppose sometimes if they say that the input power is something or output power is something, sometimes they will give the input power, and they will give the efficiency. Input power they give, and they give efficiency or percentage efficiency they give. So all of us know that percentage efficiency is equal to output power by input power into 100. So we can definitely calculate from here output power. Output power will calculate as percentage, that means efficiency by 100. Suppose they have given 80%, so 80 by 100 into the input power. And in this formula, what we are using, this power is the output power only. It's not the input power. This is the output power. That's why I mentioned here this is output. Okay. So 100% efficiency. If not given, you take 100% efficiency. But generally in some questions they will give percentage efficiency. So you need to calculate output. Input they have given, percentage efficiency they given. You calculate output and then use this formula. You will get the intensity at this point P. And once you get intensity, now you use the formula for amplitude. So tell me the intensity and amplitude. What is the formula? This intensity is the same, right? This pointing vector. It's the average. Okay, note that this is the average intensity formula. So use this average intensity formula and calculate pointing vector. What is the formula? 1 by mu naught E cross B, E naught into B naught. And two factor comes average when you take. Remember that. Remember. This is the average intensity formula from pointing vector. Pointing vector. Average intensity formula. Right? Use this formula and calculate now. So I can write this one as 1 by 2 mu naught E naught. B naught I will write as E naught by C. This I can write. Or see the average intensity formula you can write as energy density into speed of light. That also you can do. If you want that also you can do, because you can convert, right? See, you need to convert. See, right? You can convert that. Okay. So I'm keeping in terms of this only. So let us do the calculation of electric field amplitude. So from here E naught square becomes 2 mu naught times C into average intensity. Now average intensity you will substitute from here and you got E naught. E naught will be under root of that, right? Let's write one more step. E naught is under root of this. 2 mu naught times C into I average. Let us substitute that. So root under 2 mu naught into C I average from there. So power output divided by 4 pi r square. I hope you got this, right? That's what it is. The amplitude of electric field at a distance r from the source. Clear? Okay. Then if they ask magnetic field amplitude, once you got E naught, B naught is equal to E naught by C. That you can do the calculation. That's not a big thing. Okay. So this calculation can be done. Also, there is an important point to note that uh, rate of photons, rate of incidence, or rate of photon emission from source, rate of photon emission from source. So suppose this is a source, that means it is a source of light or electromagnetic wave, and as we discussed that it is emitting photons. Photons is going away from this in all radial directions. Okay, these photons are going. So let us say the total number of photons it is emitting is n and time taken is t. So already we know what is power. Power is total energy n into E by t. So the rate of photon emission is nothing but n by t. N by t you can calculate. N by t is P by E. So that is what is rate of photon emission. You have to remember this formula. Rate of photon emission N by T is equal to P by E. sometimes they will say that, let us say that this is a source which is producing 100 photons. Okay, let us say that this is a source which is producing 100 photon per second. It is producing 100 photon per second, but when I want to calculate the intensity at this surface, when I want to calculate this surface is at a distance r, here all the photons are not reaching in the same time. Suppose 100 photons are produced, same 100 photons are not reaching there. Maybe some photons are getting lost here and there. So that is an important thing here which you need to note. So suppose here let us say that it is emitting n photons, or let's say n1 photons in n1 photon per second, let us say n1 photons per second, n1 photons per second. It is emitting, that is the rate n by t. Okay, but the photons which are reaching here at the surface is n2 photons, n2 photons per second. So then what? So we have to go back to the basic to write the intensity. So if you want to calculate intensity here at the surface, then you have to write total energy received. The energy received is n2 into energy of photon. Of course, energy of photon will not change. That's the same. N2 into E by T. T is like 1 second here, you can say. 1 second, right? N2 photons produced. Number of photons, total energy, time, area. Area, of course, is 4 pi r square. Okay. So that's how in the calculation N2 will be used, not N1 will be used. N1 is the power, output power. Output power calculation will involve N1. Okay, but to calculate intensity there, N2, that N2 will be used there. You may take time as t second, or one, I have taken 1 second. Okay, so you can take t also, that doesn't matter. But the thing is that the photons which are emitted here, all photons are not reaching to the surface. Clear? So you need to read the question clearly and then solve. Okay, then this type of things you can do, right? Any type of questions are there? And one case study I will discuss for a sphere, where you will see how to use. In the book it was given wrong, so might be people get confused. So I will discuss that. Okay, it's a case study of force, radiation force, radiation force on a sphere. This sphere can be purely reflecting, it can be purely absorbing, or it can be partially absorbing and partially reflecting. Okay, so now let us try to understand that what is the question or what is the case study. Case study is that there is a sphere here. This is a sphere. Okay, and a parallel beam of rays are coming. This is a result that I will derive. You note it and use it in the problems. So suppose that light beam is coming, light is there or electromagnetic waves are there. It is coming like this. Okay, like this it is coming. And let's say the radius of this is capital R. Radius of this is capital R. We can take each case reflecting, absorbing, and partially reflecting. Okay. The question is, what is the force acting on this? What is the force acting on this? How to calculate it? So first case you take purely absorbing. Okay, purely absorbing case will become very easy. First let us take purely absorbing. Purely absorbing. So when you take purely absorbing case, You know that these photons are coming. These are the photons which are going to hit it. Right? These photons will be hitting it in this horizontally direction. Will be hitting it like that. So if I consider this surface like this, and this is the photons which are going to hit here. Photon is going with the momentum p. After that, the surface is absorbing, so total momentum is getting lost. So you can say final momentum is zero. Right. So initially, before hitting the surface, it has momentum p. Finally, after hitting the surface, it has momentum zero. Correct. So now the thing is that I want to calculate the uh, force. Force I want to calculate, and this is along x-axis. You can take that. Suppose the area which you take here, this small area is like this way, not a flat surface, but it is like this way. So it's a part of a sphere, right? It will be like this. This is the area on which it is hitting. I will draw a little bit bigger version of that. So the area is like this way, part of this. But the photon which is hitting it, that photon is just like a particle you are taking and it is going like this moment. After that, this area is absorbing it, you can say. So that becomes zero. But you want to calculate the force, right? You want to calculate force means the momentum change is happening in this direction, x-axis. You can say the change of momentum happening along x-axis is final momentum is zero minus initial momentum is p. So change of momentum of the photon is minus p. Okay. So if I want to calculate force is along x-axis only. So change of momentum divided by time taken. Okay. So and you remember this is minus p by time, and momentum of the photon is e by c. Remember, momentum of photon is e by c. Why it is e by c? Because according to de Broglie equation, which is h by lambda, and then I multiply with frequency in the numerator and denominator. That's why become h into f become e, lambda into frequency becomes c. So photon has a momentum. Okay, so we'll substitute that. So force acting along x-axis is minus E by this force is acting on what? On photon. Okay, note that this force is acting on the photon because we are studying the photon. So this is the force acting on the photon. It is negative. Why? Because it is acting in this way. But if you see force acting on this part of this sphere, it will be acting in this way. Both will be, magnitude will be same, but the direction will be opposite. Because one is like action and another is reaction. So when you calculate this, you may write this as minus fx because opposite of this. So E divided by C delta 2, right? This is the force. Rate of change of momentum. And if I have to calculate pressure, then we will calculate force by area. Right? So if I have to calculate pressure is equal to, and note that energy by time, here this energy means total energy of course. This energy means how many photons are hitting per second. So we have taken an one photon, but total photons will be imparting that. So total you have to consider. So you may write this as energy by time is power. Power by C also you can write. So pressure when you calculate, so force will be minus P by C. But when you calculate pressure, so pressure is equal to what? Force by area. This force by area you have to take. Let's take magnitude of that, okay? Because you will calculate force on this. So that will be P by power, this P is power by C, and this area. So power by area become intensity by C. That's what it is. Right? But note that here when you are calculating, you are considering this small area, na, because you have taken a small. But when you calculate here, you need to consider the projection of this areas. The projection of this area will be the vertical portion. So that means for this entire sphere, this sphere when you are taking, you need to consider the projected area which is like a circle. This projected area you have to take. So now this was means for single photon hitting and that is small area. So this force which we are calculating is a very small force because it is on a small portion. But you want total force, right? So that's what you have to do integration. So when you do integration, you can use this idea of projected area. So radiation force, if you have to calculate radiation force on a sphere, on the entire sphere, if you have to calculate, that will be this pressure I by C into the projected area. Projected area is a circle, so I by C into pi r square. This is the formula for this. Okay. Remember this formula is when purely absorbing it is. Purely absorbing, this is the formula I by C into pi r square. But now suppose it is purely reflecting, so little bit you have to go inside the calculation and do like this. Okay. Here you will be taking area like this, and let us say photon is coming with a momentum in this manner. This momentum is coming, and here this center, let us say center O, you join this line, and you need to resolve this momentum in two direction. Let us say that this is making angle theta here. This also will be angle theta. This momentum you have to resolve into two components. One will be in this direction, one will be this direction. This momentum is p, right? This is p, so in this direction this is theta, so this is also theta. So this direction will be p cos theta, this direction is p sin theta. Right? Reflection you are considering now. So now if you consider reflection, so this will also go like this way according to the law of reflection p. And this is also going to be theta. So this momentum is getting reflection like this also you will resolve. This side also p cos theta will come and this side p sin theta will come. So if you are going to see force this p sin theta, there is no change, right? Because horizontally p sin theta this way, p sin theta this way. Only p cos theta direction is changing. So p cos theta it is hitting radially, and this is p cos theta it is coming out radially. Remember this is the direction of radial. Radially we are seeing, right? P cos theta radially going inside, coming out. So the change of momentum happening radial direction, let us write radial direction change. Change, you know, these are two opposite directions. So when you subtract, they get added up. So 2p cos theta, that is the change. But this change is happening on this very small area, right? Very small area. So we are studying this small area. And if you consider this area here, this area will be like this, because when you are studying this portion, symmetrically this area will be going like this way. So on this area, these forces are acting, but these forces are radial forces. So we are taking radial forces. Radial forces we can calculate, but this is a very small radial forces. So small radial forces we can calculate. That radial forces will be this change of momentum that has happened, right? So change of momentum divided by time. You can do that, or you can use that pressure into area. Pressure is what? Pressure will be due to this change, and it's reflecting, right? So that you can directly also use, or if you want, you can use this, or you use directly 2I by C for purely reflecting, right? 2I by C it is, and this area is small area to use. That's the small force. That small force is acting on these areas. All this is small areas, right? But now I want to resolve it, this force. Why we want to resolve? Because let us say if you take this and this point, these forces will be acting like this, radial force. And if you resolve this into two components, one will be along this and another this. Here also along this. So you will see that what will be that angle. You see here, this direction is making no angle theta with horizontal. So this is making angle theta with horizontal. Similarly, this is making angle theta with horizontal. So this component means radial component cos theta, and this is radial component sin theta. Similarly, here also this is radial component sin theta, and this is radial component cos theta. So you will see here that this radial sin theta component cancel out, only cos theta component remains. So basically what you need to do is, if you want to calculate the net force, you have to integrate this radial component along the horizontal direction. Now very important thing, when you are doing this integration, this force formula already I said 2I by C. 2I by C is the force formula, and also note that here area is also multiplied. 2I by C into small area dA, you have to multiply with cos theta. Okay. Now dA, how do you calculate this dA? To calculate this dA, you think about this one. Okay. To calculate this, you think about this line. How much is this? Because this radius is r, this is theta, so this is r sin theta, right? R sin theta, and a small width of this is like an arc length. That arc length, let us say this angle is small d theta. This arc length is r d theta. So this small area becomes equal to the circumference, which is 2 pi r sin theta, multiplied with this thickness, which is r d theta. Okay, so that becomes 2 pi r square sin theta d theta. So that's the term which is coming area dA. Let us substitute this area dA. So here when you substitute, so 2I by C you take out, it is constant. dA you got as 2 pi r square sin theta d theta, right? Then you have to also multiply with this cos theta, right? Check out this 2 pi r square sin theta d theta, and you have also multiplied with cos theta. So what do you get from here? How much do we get? 2 into 2, 4 pi r square I by C. Then it will become sin theta cos theta d theta. Check out this. This is correct. Did I miss anything? df radius cos theta I have taken. That integration df I have written as 2I by C dA. 2I by C dA I have written. Is this correct or not? Or did I make any mistake? One minute. Here when we are taking this rate of change of momentum in this direction, so radial force when we will write, we'll write divided by time. Uh, when we write divided by time, suppose if I calculate from here, I think I should calculate from here. So delta T radial change by time when we take, that become 2p cos theta by time, right? And momentum I can write as E by C. E by C if I write, E by C I will write delta T cos theta. That is the radial force dF radial force. Okay, so in the radial force also there is one component is also coming, hmm, energy. Energy by C delta T also. So one cos theta also comes here. Okay, this is what one additional factor of cos theta will also come here in df. So in df one additional cos theta factor will come, and then that term will come here. Extra cos theta factor will come. So this and extra cos theta factor is also coming here. So when you do this calculation, what do you get? That is where mistake is in the book. Okay. So extra cos theta means cos square theta factor will come. Cos square theta factor will come. Right. And this then you have to integrate from 0 to pi by 2. And this integration gives the result. This integration, you can do this integration by substitution, that gives 1 by 3. So this extra factor 1 by 3 factor comes. So this is the force formula. This is the formula for force. Which case this formula for force is what? In reflecting, purely reflecting, purely reflecting. So remember this formula here, 1 by 3 factor comes out. 4 by 3 factor comes out, and if it is partially reflecting, if it is partially reflecting, and let us say the coefficient of reflection is AR. AR is the coefficient of reflection, coefficient of reflection. Similarly, partially partially absorbing, that coefficient is A. Let us say absorbing. This is the coefficient of absorption, coefficient of absorption. So the formula for force along x-axis will be pi r square into I by C multiply with the coefficient of absorption plus 4 by 3 pi r square into I by C multiply the coefficient of deflection. Now you may ask, what is coefficient of absorption and reflection means? The coefficient of absorption and reflection means percentage. Suppose they say that 50%, or let us say they say that 20% absorption. 20% absorption means coefficient of absorption is 0.2. Okay. And suppose they say 80% reflection. 80% reflection means coefficient of reflection is 0.8. I hope you got this idea. Coefficient comes from percentage of absorption and reflection. So this formula we can use to get that. This is a case study, very important case study for difficult problem. If it is coming, then you can use this final formula. But try to understand this, that is more important. And see, go through the derivation. If any doubt is there, we can discuss. But in the book, they have not multiplied one extra cos theta, which I was telling. Why? Because this momentum itself is coming in terms of cos theta. Okay. Anyway, just to go through this, we'll see that. So done. We are done with this chapter. Next class, we are going to start ray optics. Ray optics will start, and then we'll move forward with the next chapter. Fine. Okay. Okay. Then we'll meet in the next class. Bye bye all.